Hello everyone, welcome back to this video series on clinical SAS SDTM programming. In this video, we will see how to create adverse events dataset. So let us go to the concept description and then we will see the lesson description, specification and how to program it. So some background about adverse events. So in clinical trials, when taking a drug or investigational product, the trial participant may experience some untoward medical occurrences along with the intended benefit of the drug. So these untoward medical occurrences are called adverse events. So the formal definition of adverse event is an adverse event is any untoward medical occurrence in a patient or clinical investigation subject who is administered a pharmaceutical product and which does not necessarily have a causal relationship with this treatment. So an adverse event can therefore be any unfavorable or unintended sign, including an abnormal laboratory finding, symptom, or disease temporarily associated with the use of a medicinal product, whether related to the medicinal product or not. So let us see what is some information that is typically collected for adverse events. So the term described by the subject to explain the adverse event. So we call this as verbatim and we collect that. And then the start date time of the event and status of the event, whether it is ongoing or ended. If it ended, then we will collect the date time when it actually ended. And then the severity of the event, whether it was mild or moderate or severe. And then the pattern of the event if applicable. So whether it occurred only once or whether it occurred intermittently. So that information will be collected. And then any additional medication given or taken to treat the event. So if say for example, if the subject has experienced headache, so he or she might have taken some medication to get that relieved. So we are collecting if that any medication is given or taken to treat that specific adverse event. And then if applicable, the location and laterality of the event. And then some investigators assessment related questions will be there. So the investigator would try to make a judgment whether that drug adverse event is actually related to the investigational product. So whether relationship or causality to the study drug. And then relation to non-study treatment. There can be cases wherein the subject may be taking other non-study treatments. So investigator would try to evaluate whether the adverse event could be because of that non-study treatments. So investigator would also evaluate whether the adverse event is serious or not. So if the investigator is considering it as serious, so there are for an adverse event to be called a serious adverse event, certain conditions have to be met. So if the adverse event has resulted in cancer, or if it caused some congenital anomaly or the birth defect in the newborns on the patients who are taking study drug, and if it caused persistent or significant disability or incapacity, or if the event resulted in death of the subject, or if it is considered as life-threatening, or the event caused hospitalization of the patient or resulted in prolonged existing hospitalization. So if any of these conditions are met, then the event would be considered as serious. So investigator would evaluate all of these conditions and then decide whether the event is serious or not. And then, so based on his evaluation, so the investigator may take a decision to stop the drug or adjust the dose or take any additional action. So that action taken with the study treatment would be reported or collected. And then did the event occur with overdose of study medication? So investigator would also try to evaluate was the adverse event because caused because of taking overdose of the study medication. So this kind of information would typically be seen in adverse events dataset. Now let us move to the description. So what will we see in this lesson? So we will see how to write a programming specification for AE domain, and then if you are a programmer, how to interpret an existing SDTM programming specification, how to program as per the specification, and how to so as part of the programming we will see how to convert raw dates to ISO 8601 notation, and then we will see how to create study day variables, how to derive epoch variable using subject elements dataset, and then how to create sequence variable, and how to assign labels for variables using attribute statement, and then how to create a supplementary domain. And then we also see how to convert a SAS dataset into XPT format using proc copy and export engine of libname statement. So let us now move to the specification. So here we have the variable name, the variable label, and the derivation logic is given. So the main dataset that we will be using as input for creating SDTM AE in this lesson is called adverse. So for study ID variable, we are being asked to use the study variable from adverse events, adverse dataset in. So for creating study ID variable, so we are being asked to make it as a copy from study variable of adverse dataset. And then for domain, so we are being asked to uh, assign the text AE, which is the abbreviation for adverse events. And then for use sub JD, so we are being asked to derive it by concatenating study and PT variables from our input dataset. And we are also being asked to separate them with a hyphen in between. And then we have AE-seq variable. So it says sort the records by use sub ID, AE decode, AE STDTC, and then set to 1 on the first record for each subject and increment by 1 for each subsequent record within the subject. So we'll have to sort the dataset first in the by the specified variables, and then so if there are multiple records within a subject, so we are being asked to set the value of 1 on the first record, and on the subsequent records of that subject we are being asked to increment it. So if we take a look at 1003, so this is the first record, so we are setting it as 1, and the subsequent record we are being asked to increment. So this is the second record. If the subject had 10 other records, so we would have incremented it till 10. And then we have our next variable, which is AE term, the label for which is reported term for the adverse events. It says equals to the value of AEVT from our input raw data set. And then AELLT, so again here it is a copy of the variable named AELLT, and for AE decode it is a copy, and AE cat is also a copy with the same named variable in the input dataset. AE bodysys is also the same case, so we have already the variables which are required in SDTM with the same names, we have them in input data, so we'll be just assigning them or just use the existing variables. And then we have AE save, so it says equals to the value from AE save after converting to standard control terminology. So we have the values as yes or no in AE save variable, but as per the well, it's not yes or no for AE save. I think let's take a look at the input data, adverse events dataset, AE7 mild, severe, moderate. So in order to convert it into standard control terminology, we need to convert it into uppercase. So we'll be converting it into standard control terminology. And AESCR, so again we have the same named variable, but we are being asked to convert it into standard control terminology. So equals to for AEACN, so we have the same named variable, but we are being asked to convert the values to standard control terminology. And for AEACN OTH, which is other action taken, so again we have the same named variable in our raw data set, so we'll be using that as a direct copy. And then we have AEREL, which is used to capture the causality of the study drug for the adverse event. So equals to the value from AEREL, but after converting it to standard control terminology. AE out again, so after converting to standard terminology from the same named variable in the input dataset. And then we have AESCONG, for which we have a raw variable named SCONG. So we'll have to use this variable, apply standard control terminology, and store it in AESCONG. And similarly, we have AEDSAB, AESDEath, AESHOSP, AESLife. These are all the variables which capture the subclassification of an event being serious or not. So we have SCONG, SDISAB, SDDeath, SHOSP, SLife. So and we'll use this information and convert this into standard control terminology and store in the associated variables here. And then we have epoch variable definition, which says derive by comparing AE_STDTC with the SC_STDTC and SCENDTC of each element of a subject and assign the epoch based on the SDTM SC epoch of the element in which the start date of the event start date falls. So we know that in SDTM SC we will have one record per uh, element, and we'll have to convert that into one record per epoch. So and then we'll have the start date and end date of each of the epochs. So and again, so in we'll have to check where this AESTDTC is falling on. So whether it is falling in between the start and end date of screening epoch, or in between the start and end date of treatment epoch, or between follow-up epoch. So if it is falling, if the AESTDTC is falling in between the start and end dates of the treatment epoch, so we would assign the epoch as treatment. But if it is falling in between the start and end dates of follow-up, so we would assign the epoch as follow-up. So this is what the specification is trying to convey. And then we have AESTDTC. So we are being asked to use the value from AESTDT underscore raw and convert it into ISO 8601 notation. Similarly for AEENDTC, so we are being asked to use the variable named AEENDT underscore raw after converting it into ISO 8601 notation. And then we have study day variable for start date of the event and end date of the event. So it says if the event date is on or after reference start date, then AE_STDTC minus RF_STDTC plus 1. Else if the date is before reference start date, then assign as AE_STDTC minus RF_STDTC. So we may have one or more records per subject. So let's say this blue color indicates the reference start date of that subject. So if the date on a particular record is on or after reference start date, so we are being asked to take the difference of between date and RF_STDTC and add plus 1 to that. Otherwise, we are being just asked to take the difference between these two variable values. And then similarly, we will derive AEENDY, but instead of using AESTDTC, we will be using AEENDTC. So we'll use the same logic here. And then we have this variable called preftos, which is collected on the CRF to indicate whether the event occurred prior to first dose or not. So and then we'll just, it is again a copy from the raw variable name. And then we have this AETRTEM, so which is treatment emergent flag. So we are being asked to derive it using the information present in preftos and comparing AESTDTC with RF_STDTC and RF_XENDTC. If adverse.preftos is equal to y, which means if the event started prior to first dose, then set AETRTEM to none. So we are basically trying to check if the adverse event started on or after treatment start date. So if it's already indicated in this variable that this event has occurred prior to first dose as y, so this is not treatment emergent. So we are being asked to set it to n in that case. Else if AESTDTC is on or after RF_STDTC but before RF_XENDTC plus 15, so we are being asked to set the value of AETRTEM to y, otherwise to n. So in all the other cases where it is not falling in between RF_STDTC and 15 days of RF_XENDTC, so we would set it to n. So this completes the specification understanding for our adverse events dataset. We will now move to the programming. So here on the left hand side I have my program, on the right hand side I have my input datasets and the intermediate datasets that are getting created and the final dataset. So let us try to go through the program. So here I am using my input dataset adverse and creating a dataset named as AE01, and similarly for DM and SC. So I am creating datasets named DM01 and SC01 to use in the program. So here on the right hand side, if we see the main input dataset, which is adverse. So we have study, PT, AECAT, verbatim, preftos, start date raw, end date raw, severity, and many other variables which we will be using to derive our SDTM AE. And then we have our DM dataset in which we will need RF_STDTC to derive our study day, and we also need RFXE and ETC when deriving our AE, TRT, EM. We have seen in the specification. And then we need SC to derive our epoch variable in AE. So we will be using these three data sets as input to complete the programming of AE. So now let's come to the main aspects of the program. So what we are doing here is we are creating variables which are directly based on the existing raw variables which from the primary input dataset, which is adverse. So we have created a copy of adverse as AE01. So we are using that here and in the set statement and creating a new dataset called AE02. So what are we doing here? So we are filtering only those rows where AEVT not is equal to missing. So let's see if there is any record which uh, has AEVT as null. So in some cases where what will happen is the same form would be used to collect whether so let's not go into those exceptions now. So we are just filtering only on those records where the subject has reported an event when we have that verbatim reported. So we are filtering those records. And then for study ID, so we were asked to use the value from study variable. So we are doing that here. And for use ID, we were asked to concatenate the values present in study and PT with a hyphen in between. So we are making use of catx function to do that. And for domain, so we were asked to use the value of AE, and so we are assigning that here. And for AE term, so we were asked to use it as a copy of AEVT, so we are doing that here. And there were some other variables uh, which are having the same name as an SDTM present in the input dataset. So just to make sure that the derivation logic is not missed, so I'm just assigning the same named variable on the left hand side and right hand side as well. AELLT, AE decode, AE cat, AE baud and for AE severity, so we were asked to convert it into standard control terminology. The values present here in AE7 are in lowercase. As per the standard control terminology, these have to be in uppercase. So I'm applying that uppercase function to convert them into standard terminology. And then for AE SCR also, we were asked to convert the existing values with the same named variables into standard control terminology. So here the control terminology is being applied as if it is yes, so we have to present it as y. Otherwise, if it is no, so we have to present it as n. So we are converting it into standard control terminology, the existing raw values. And then for AEACN also, we were asked to convert it into standard control terminology out of all the possible values here. So there is one term which is called no action taken. So for which the standard control terminology is dose not changed. And all the other instances we just had to convert it into uppercase of the existing AEACN value. So we are doing that here. And for AEACN OTH, it is exact copy of the value present in uh, our input dataset. So we are assigning it with the same name. And then similarly for we have seen it for AESCR. So in all the input raw datasets, we have the values collected as yes and no, but as per the standard control terminology, they have to be y and n. So we are making those changes for all the applicable variables of AEREL. AESCONG is being used to create AESCONG, and SDSAB is being used to create AESDISAB. And similarly, SDETH variable is being used to create AESDTH. And I think there is a minor programming issue here. So this should have been AESDTH. I'll try to correct it post making this video. And then we are using shosp variable to create AESHOSP. And then similarly, slife is being used to create slife variable. So in all these variables, so we are converting it into standard control terminology. And then we are trying to create our AESTDTC. So we are extracting the day component. If we take a look at AESTDT underscore raw, the date is present in the form of 2-character wide day value slash 3-character wide month, 3 characters month, and we have year available. So with a slash in between. So we are extracting the day component using scan function. So when we have a forward slash as the delimiter, the first word would give us the day component. So we are extracting the day component and converting it into numeric and storing it in a value called stdyn. And again we are creating another variable called stday by adding leading zeros where applicable using put function and Z2 format. And then we are extracting the three character wide month here. So JAN if we see. So we are extracting that using scan function again, and the second word is being extracted for that. And we are indicating that forward slash is our delimiter. And then we are converting that ST month. So we have the values like Jan, Feb, March collected. So we are converting that into 2-digit wide uh, month value. So starting from January with 01 to December as 1 to 12. So we are converting the month value to ISO 8601 expected notation of 01, 02 and all the way till 12 for December. And then finally we are extracting the third word, which is nothing but our year value. And then, so what we are doing here is if any of the component is missing, so we are converting it into hyphens here. So here for AESTD str if it is unknown, so we are setting it to null, and otherwise, so we are converting it into expected notation. So and we are creating AESTDTC by concatenating st year, st month, and st day. So we'll have date coming up in ISO 8601 notation when this code is run. And then similar processing is done for end date as well. So we are extracting the day component, month component, and year component from AE raw, and then converting them into ISO 8601 notation, and then concatenating them using catex function and storing the resulting value in AE. So let us take a look at our AE02 dataset to see the newly created variables. So here we have created AE in 8601 notation. So we also have AE created in ISO 8601 notation. And so if we see, there are some values in the original dataset. We had these values as YES, so we converted them into YN. And for AE, what was that variable? AESEV, so we converted the values which were in proper case to uppercase as per the standard control terminology notation. So we have done this processing to create variables which are directly coming from our input data set and made some minor modifications as per the specification requirement. Now let us move to the next step. So what are we doing here in the next step is derive study day variables and AE, so in order to derive study day variable, what we need is we need our reference start date in our adverse events dataset. So we are merging our demographics dataset to our adverse events dataset and at subject level and keeping only USUBJD, RFSTDTC and RFXE So RFXE and ETC is fetched in this merge so that we can use it in the creation of AE RFSTDTC is needed for creation of study day. And here we are, for the study days to be calculated, we need the date components to be available in numeric format. So we are using input function with YYMMDD10 format to create numeric counterparts for reference start date, AESTDTC and AENDTC. So we are naming those numeric variables as RFSTDT, AESTDT, AENDT without having the C as the suffix, so that we will be able to easily use in programming. So we are, and again here we are creating numeric variant for RFX ENDT as well. So as per the definition of AETRTEM, so we were asked to check if AESTDTC is falling within 15 days of RFX ENDT. So we are creating a numeric character date value by adding 15 days to the numeric RFX ENDT and then converting it into again ISO 8601 notation using put function with YYMMDD 10 dot. So we'll get a better understanding when we take a look at the data values. So we'll see that in a while. And then here what we are doing here is, so we are checking if AE and DT is not equal to missing and RFSTDT is not equal to missing. So we are, where do we have AESTDY variable derivation? Okay, so here in this code, I have demonstrated two ways of creating study day. So here first we are when creating AESTDY. So I am using this concise formula, so which I have used in most other SDTM dataset codes as well. So here I am checking if both AESTDT and RFSTDTC is present or not using n function. So n function, if we pass a list of variables to it, so it returns the number of variables with a non-missing value present in it. If both AESTDT and RFSTDT has non-missing values, n function would return the value 2. So which means if both of them are present. So when I'm checking for is equal to 2, what does this mean is, so both AESTDT and RFSTDT does not have a missing value, then go ahead and create AESTDY. So AESTDT minus RFSTDT plus AESTDT greater than or is equal to RFSTDT. So when this condition is true, this would become 1, otherwise this would evaluate to 0. So as per the definition, if it is on or after, we were supposed to add 1 to the difference of these two dates, otherwise we are not supposed to add anything. So which is what we are handling in a programmatic fashion. So but in the case of AENDT, so I have used if then else logic to show you the both work the same way. So if AENDT not is equal to missing and RFSTDT not is equal to missing, then do. So if AENDT is greater than or is equal to RFSTDT, then AENDY is equal to difference of these two dates and then add 1 to that difference. Otherwise, so AENDT minus RFSTDT. So you could create your study day variable using this logic or this logic. So here this addition of +1 is handled in a more logical way of evaluating this expression. So 1 will be added if it is on or after. Otherwise, nothing will be added. So these are two different approaches of creating your study day variable. And then we are creating our AETRT EM variable. So the specification said if pref dose is equal to y, which meant that the adverse event was already present before the first dose is given. So we cannot call that events as treatment emergent. So we are setting that AETRT EM to n. Else if we are checking whether our AESTDTC is in between reference start date and 15 days of our RFXC and DTC. So this variable we have created it by adding 15 days to RFXC and DTC. So we have first converted the RFXC and DTC values to RFXC and DT, which is as a numeric value, and to which we are adding 15 days and then converting it into character value here again. So we are using that 15 days plus RFXC and DTC value here to check whether it is falling in between reference start date and RFXC and DT. If it is the case, so we are setting the TRTEM value as y, otherwise we are setting it to n. So let us take a look at our AE03 dataset to see if our study day variables are created and also our AETRTEM. So we have our AESTDY calculated, AEENDY calculated, and AETRTEM populated. So we have one record where AESTDY is coming as null. So let us try to check why that is the case. If we see here, AESTDT is null. The numeric variant of AESTDTC is coming as null. So let us go back and see what is the original value in AESTDT raw. So here we have a partial date. So we do not have the day component present. We only have the March month as March and year as 2010. So as this cannot be converted into a numeric date value, we will not be able to derive study days on those cases. So this is coming as expected now. So we have not missed anything so far. So let us now move on to the next step. So then we are creating our epoch variable. So for epoch, so as per the specification, what we were asked to do is check where exactly this AESTDTC is falling in which of the epochs. So we will see how this is being processed. So we will process such that we will have the start and end dates of each of these three epochs on a single row. So we will process our SE dataset in such a way that we'll have start of screening and end of screening, and start of treatment and end of treatment, start of follow-up and end of follow-up on a single row per subject, so that we can compare our AESTDTC in on which of the intervals it is falling, and then we will assign the epoch accordingly. So here we are creating a temporary variable called short by extracting the first character from epoch variable. And then we are transposing our SC which is nothing but the start date of the epoch, and we are keeping useObjd in the by variable and specifying that the newly created variable names have to be coming from the value present in short variable. And then we are also indicating that the newly created variables should have a prefix of s. So let us take a quick look at our SC02 first and what we have done. So here we have extracted the first character from our epoch variable for screening. So here if we see, so we will get that s value, and for treatment, so we are extracting this t first. And then we are transposing the start date and storing the resulting value in the dataset named epoch start. So let us take a look at epoch start. So here we have got one record per subject with the start date of each of the elements. This s we have added as prefix. So, and this second character is nothing but the indicates the whether the date corresponds to screening or treatment or follow-up. So this s as we have added as prefix, so to indicate that these dates are the start dates of each of the epochs. So start of screening, start of treatment, and start of follow-up. So in the next step, we have transposed our SCE and DTC, which is the end date of each epoch. So let us take a look at epoch end. So and here in this case, here we have used prefix as S for start, and we are using a prefix of E for end date. So here now we have end of screening date, end of treatment date, and end of follow-up date. So we wanted both start and end dates to be present in the same dataset. So we are merging our epoch start and end date datasets into a single dataset and calling it as epoch dates. So let us take a look at this one. So now we have start dates and end dates of each of the epochs of a subject on the same row. Now we need to pull this information into our adverse events dataset so that we can check where our AESTDT is falling, whether it is falling in between the start and end date of screening or start and end date of our treatment or start and end date of our follow-up, and then assign the epoch accordingly. So we are merging epoch dates to our AE dataset again at subject level and naming the dataset as AE04. So here we are creating some temporary variables. So we are assigning our AESTDTC to YMD variable, and then we are creating a variable named YM to store the year and month component in this variable from AESTDTC in this variable, and then we are extracting year component from AESTDTC and storing it in a variable named Y. So we are checking if the date is full. So we know that as per ISO 8601 notation, if the date is full, the overall number of characters would be 10. So when the date is full, so we are checking if the adverse event start date is falling in between screening start and less than end of screening. So what we do is like we assign if we go back to the specification, if a value falls on the boundary of between two elements, so here we are giving preference for treatment epoch. So if a date if an adverse event started on the end date of screening, so which is again equivalent to the start date of treatment, because this is the structure of SC. So you cannot have gaps between two elements. So we will be giving preference to treatment epoch if it is falling on the boundary of screening and treatment, and again when the record is falling in between the boundary of treatment and follow-up, so we will give preference to treatment again here in this data set. So we are checking if screening date start is less than or is equal to adverse event start date less than end of screening, or if the subject has not started treatment, so we are assigning as screening till the end date of screening. But if the subject took treatment, so we are considering only till less than end of screening. If the subject did not take treatment, so we are considering till the end of screening for screening epoch here. So and we are when either this condition is met or this condition is met, so we are assigning the epoch as screening. Otherwise, we are checking if our AESTDTC is falling in between the start date and end date of our treatment epoch, and if it is met, we are assigning it as treatment. And we are checking whether otherwise if it is not falling in any of these two first if then else conditions. We are checking if it is at least falling in between the start of follow-up and end of follow-up, and then assigning it as follow-up here. And similarly, we are checking if AESTDTC's length is equal to 7, which means we have a partial date. So we are checking if it is, here we are extracting the first 7 values, which will be our year and month from start of screening, start of treatment. So we are making our comparisons with the start, year and month of start and end of each of the epochs. So when we have only year and month, so the comparison has to be made at the same level. So we are checking if sub-STRN of SS1 to 7 will give the year and month of screening start, and then we are checking if our adverse event start date is falling in between uh, start and end date of screening, and if that is the case, so we are assigning the value of screening. And similarly, we are checking for the conditions of treatment and then also follow-up. And then we will now move to our AE-seq variable. So let us take a quick look at our AE05, the data set that got created, AE05, and see the epoch variable. So we have our epoch variable derived here. So let us now see the next variable, which is our AE-seq variable. So we were asked to sort the data based on U sub ID, AE decode, and AE STDTC. On the first record of each subject, we were asked to set the value of 1 to AE-seq. Otherwise, we were asked to increment it by 1. So we are achieving that using this code. And then finally, we are assigning the list of variables which are specified in the specification to a variable named var list, and we are writing variable labels using attrib statement for all the variables which are required, and then keeping only the required variables as per the specification. And then, so there were two variables which were preftos and AETRTEM. So these are meant to be going into our supplementary dataset. So we are creating our supplementary dataset in the next section. So we are indicating that the two variables which have to go into supplementary dataset and assigning them to a macro variable called subvars. And then we are sorting the dataset, our final AE dataset AE07, and creating a new dataset called sub AE01 based on the values present in study ID, domain, U sub ID, and AE-seq. And then we are transposing these two variables so that these two variables will now become rows as per the expectation. So those should become two different rows, for creating our supplementary domain. So let us quickly go to our SUPAE02 to get an understanding on how that is transformed. So if we see in SUPAE01, so we have preftos and AETRTM as two columns. So we are creating these as rows now, and those two variable names are coming in a variable named qnam and then qlabel. So we have transposed the variables. Ampersand subvars is being used, but ampersand for subvars, so we have assigned the two variable names here. So we are transposing those two variables by study ID, domain, U sub ID, and AE-seq. Study ID, domain, U sub ID, and AE-seq. So these would be present as rows, and the two additional variables that were present as columns are now coming as values in the qnam variable. So how did we do that here? So we have used the name is equal to option and proc transpose by default. So the names of the variables that are being transposed would have come in a automatic variable named underscore name underscore, and the labels of those variables would have come under an automatic variable name underscore label underscore. So instead of using the automatic variable name, so we can use the option name is equal to specify the name of the variable, so that will hold the names of the variables that are transposed. So indirectly we are renaming the underscore name underscore variable as qnam. Similarly, we are making use of the label is equal to option on proc transpose statement to specify that the labels of the variable that are being transposed should be present in a variable named label instead of the automatic underscore label underscore. So we have done the transpose, and the associated results would come in a column called col1. So I am renaming that as qval as per the expectation of the supplementary domain. So I have created exclusive video on how to create supplementary video under tasks SDTM general concepts. So if you are looking for better explanation there, so you can go and watch that video. And then finally, I am writing attributes for the supplementary dataset, and then I am creating ID var. So here the value present in AESEQ would be stored in ID var value. And then for our domain, so I am assigning the value for our domain, and then keeping only the required variables. So let us take a look at our sub A03 here. So study ID, our domain, usubj ID, ID var val, qnam, qlabel, and qval. So these are the expected variables in our supplementary dataset, and the two variables that were transposed are pref dose, which is prior to first dose, and then a treatment emergent flag. And then finally we are creating sorting the dataset and storing them in permanent copies, and then we are creating XPT files here. So you can follow this from the code itself. This is how you can program your adverse events dataset. Thank you for watching and keep learning.